Good morning, everyone. Thanks for coming. Everybody hear me in the back? Okay, great. I know it's a little bit early. The partying hasn't stopped, I guess. But, I really want to thank you all for coming. I know it's a little early. But we will talk about NoSQL and Couchbase. Just to get an idea of how many of you are already using Couchbase or some other NoSQL technology and are very familiar with it. Maybe 5 or 6 people. Okay, yeah, that's good enough. That's kind of what I get. So what I'll do is we'll do a very quick intro of NoSQL and what it is. This is not by any means a session on NoSQL, okay? But a lot of these concepts kind of translate across the board to several of these technologies as well. So by introduction, my name is Raghavan Srinivas. I work as a developer advocate in Couchbase. If any of you have used the SPY memcached libraries, most of the recent bugs are introduced by me, okay? So I'm working towards fixing them. Matt Ingentron, he originally was the creator and maintainer of SPY. So most of the older bugs was Matt. So let him introduce himself.
Yeah, Dustin Sallings wrote it originally. I just maintained it for a while. So yeah, but now we have a number of other fingers in the pie, as it were.
Yeah. So I go by Rags. Feel free to call me Rags, and Matt goes by Matt. So it might be difficult to get either of our last names. Okay. So very easy to reach us: rags@couchbase.com or matt@couchbase.com. Okay. We still have first name at couchbase.com. All right. So the agenda for today in the next 55 minutes or so is kind of do a quick intro and then look at document access using primary keys, because 80 to 95% of the use cases are going to be based on primary keys. But we have a really cool feature using views. This came from the CTO of Couchbase, who originally was a contributor for CouchDB by the name of Damien Katz. A concept of what is referred to as views and queries. It's based on a incremental MapReduce technique, and we'll talk about that. This is a feature that's new to Couchbase Server, so you need the latest Couchbase Server to be able to do this. And really what it enables you to do is to do secondary indexing as long as you persist your data in JSON, and we'll talk about that. We have a bunch of demos planned towards the end of the session, depending on how the network is behaving, and things like that. Okay, so we will do either all the demos, some of the demos, or maybe none of the demos. No, hopefully not none of the demos, but we'll do at least some of them. Then towards the end, we have a few case studies. We'll do a roadmap, conclusions, Q&A, and we have some nice T-shirts to give away. If you ask some questions. All right. So we have a bunch of them. So we can definitely do that. Anything else you want to add, Matt? No. All right. So really, very briefly on what is NoSQL. Okay, this is a cartoon I saw in Geek and Poke. I'll let you guys kind of look through this for a little bit. Okay. So a little bit tongue-in-cheek, but you know how things start off, right? So that's the way it is. Okay. But essentially, I think. Really, it stands for not only SQL, and I think there was a product, more of an object-oriented database, probably a few years back, which was NoSQL, but somehow the name never really caught on. But roughly about 3 years back, there was a meeting where, they're trying to come up with some kind of name which not quite SQL, and they came up with not only SQL. Okay. By no means SQL and NoSQL is mutually exclusive. There are a lot of applications which can benefit from using both. But at the same time, there are a number of applications where the strict normalization rules are not really necessary, and they can be relaxed for the sake of simplicity and really for the sake of performance and so on. And that's what we're going to see today. So it's really not a single class of database. It really encompasses a lot. I'm not going to go into the taxonomy of NoSQL databases, but essentially, they don't provide a relational interface, something that you've used, known, and loved, or whatever, right? They have their own way of accessing the data. And like I said, a lot of times, some of the rules of normalization are relaxed a little bit for the sake of performance and simplicity. So they typically don't offer a lot of the RDBMS features. They're schema-less, and schema-less is probably a very strong term. It's really more of a schema-flexible. We'll see some examples today where you can change your schema on the fly, and your application is still able to adapt to some of the schema changes. I mean, does it mean that there is no schema at all? I don't think so, because you're persisting your data as JSON, and when you persist your data as JSON, there is some sense of meaning associated with the data. But if you don't persist as JSON, okay, it's just treated as a binary blob in Couchbase. Okay, there are typically not too many key constraints, no long-lived transactions, and really no concept of a join. Something that inner joins, outer joins, things that you're used to. Does that mean that you can't do it yourself? Of course you can. Okay, and we have an example, basically about beers and breweries. A very simple relationship. Beers are brewed in breweries. Breweries make beer, right? And you can kind of play around with the data and implement your own inner left join, and it's pretty trivial to do that. It's really well suited for cloud deployments. How many of you have seen this before? The CAP theorem. 2, 3, 4, 7, 10, something like that. Okay. So essentially, there are 3 properties in any distributed system. One is consistency, availability, and partition tolerance. Okay. So amongst the 3, you can have a maximum of 2 in any system, in any distributed system. So typically, you can have, not typically, but you can have only 2 properties. And typically, a lot of the traditional databases, do consistency and availability really well. And they sacrifice partition tolerance. Okay, and there is a reason, because it's really about monolithic databases, and that's kind of how it was working before. Of course, these lines are thinning these days, but the point is that most of the NoSQL databases, start off with the assumption of partition tolerance, and they either sacrifice consistency or availability. It doesn't mean that it's not going to be available at any time, or it doesn't mean that it's not consistent at all. Okay, there are degrees of consistency and degrees of availability. Okay, Couchbase itself is a CP system. Okay, it's consistent and partition tolerant. Okay. So why do NoSQL at all? Most of us start off with a monolithic program, right? And then suddenly, overnight, we become a huge success. And now we're scrambling to make it scalable. So scaling the web tier is pretty straightforward, right? You throw in a load balancer, you throw in more servers in the front end, and your application scales relatively easily. It's not that easy to do that on the data tier. Okay, just growing your database vertically, there is a ceiling. You cannot go beyond a certain limit. So then what you could do is you could say, well, I'm going to come up with my own sharding algorithm. Very simple algorithm. A to L is going to go here. M to Z is going to go here, right? But what's going to happen when you throw in the new server? What's going to happen when the server that's serving A to L, dies? How do you deal with this, right? So the application, is going to be tied very closely to the sharding algorithm, and that's seldom a good idea. So it's very expensive and very disruptive, and doesn't really, you don't want the onus of the sharding, to be really on the application developer. So the idea behind many of the NoSQL databases, including Couchbase, is that leave the sharding, to the framework, and you worry about, everything else on top of that. Okay, and we'll see with some of the demos and some of the examples today that it makes it a lot easier to scale that way. Okay, so typically, like I said, when you're scaling your database up, there is a point where you kind of hit the wall, right? You cannot keep growing, and usually when I'm in other conferences, I make a joke about Oracle, but it's Oracle Open World, so I got to be respectful to them. but you can only go up to a certain limit, right? So what you really want to do is, rather than keep growing vertically, you want to try to grow horizontally. Okay, so simply put that way. So the idea behind growing, scaling horizontally is that your curves here, which are kind of going exponentially, both the system cost, which you would expect to grow up exponentially, right, and also the application response time. Okay, you want to try to flatten it as much as possible. Okay, and that's really the idea behind NoSQL database. Okay, simply put. So as long, so what Couchbase does is it does auto-sharding, and we'll talk a little bit more about this. So for each key, there is a specific server that it goes to, and there is a consistent hash algorithm which kind of works with the network topology changes. Meaning, when you add nodes or subtract nodes, it's the client library maps is able to keep track of those changes and do the right thing for you. So you don't have to, from an application developer perspective, write your own sharding algorithm, figure out, which zip codes goes where, which has to be active at what time, and all that. Leave it up to the framework. So one of the examples that we give is, any of you played this game, OMG Pop? Yeah? Draw something? Yeah, sorry. Yeah, from OMG Pop. Yeah. Essentially, you can draw some cool things. Okay, I haven't played it much myself. Okay. But what happened was, like all of us expect, all of us want this. We want to, be a success overnight, and that's really what happened. Somebody in Jersey Shore, I don't know what Jersey Shore is. I think it's like a cereal or something. Anyway, tweeted, and suddenly it became, instantly popular, right? So you can see here they were somewhere at like 200,000 users, and they went to like 20 million users. All within a matter of few weeks. Okay, they went from like literally like half a dozen servers to thousands of servers. Okay, within a matter of few weeks. Okay, and they were able to do that because, again, the idea is that you will see later in the demo, adding servers, throwing them in, and adapting to the changes as the application is working. Is relatively straightforward using this framework. Okay. So with that, let Matt talk a little bit about Couchbase, and I'll come back and kind of do some demos and so on. Right, Matt? You can use this if you want.
Good morning. Wow, people are still streaming in. Oh, thank you. So I just wanted to spend a couple minutes talking about Couchbase specifically. The draw something example, OMG Pop actually did build on Couchbase, so when they had the need to scale that up, they did use a lot of what you're going to see this morning. So Couchbase Server itself, I just want to give you an idea of what it is. There are obviously a number of different ways that we could talk about Couchbase. Just to give you the brief definition, Couchbase Server, it's a document-oriented, flexible schema, always on NoSQL database system. So it's really designed for interactive applications. So in this world of NoSQL, one of the things that I'm going to show a little bit later is actually integration with Hadoop. Hadoop actually fits into that NoSQL category of things, and you can sort of look at Couchbase, if you will, as modern OLTP, and Hadoop as sort of modern DSS in a way. Both spread wide, both scale very well, and Couchbase specifically is trying to go after that spot for interactive applications. So briefly, Couchbase is open source, Apache 2.0 license. Some minor details on how you obtain it and so forth. And as you'll see in a little bit, it's all administered via a web console through a RESTful interface. We're actually pretty proud of that. In fact, one thing that we're really proud of is that there's not a single master within the cluster. There's not like a set of systems that manage it. You can make requests of any node in the cluster, and it will take care of whatever that request is from an administrative point of view. You can also see a lot of different statistics, as we'll show in just a bit. Available for a number of platforms, Windows, Linux, Mac. C++ is actually how the core was developed, even though some of the clustering was developed in Erlang. Question here.
Yeah, it says development only. Is that just for Mac, or is that for Linux as well?
What that's referring to is, so
That's what Mac will do.
Linux and Windows are sort of enterprise platforms. Macs, people don't usually use as servers. Yeah, no worries. It would certainly work, but we don't really run the full QA suite. We don't build like 100-node Mac clusters. That would be sort of funny. There was a point in time when Apple was doing some of that, but not so much anymore, right? It's as Rags mentioned, one sort of interesting thing is that while Couchbase is definitely a document-oriented database, it has this history from memcached and a project called Membase previously, and it actually works very well as just a distributed key value store. So there are a number of people who have, for a variety of reasons, maybe they'd written an application that was using memcached, and it was back-ending things to MySQL with some sort of custom partitioning built into the application, and it's easy to just as a colleague put it, write negative lines of code. You can go remove that portion that's putting things in MySQL and just start to use the key value store instead of as a cache, as a persistent store. A couple things on architecture. So Couchbase Server has effectively two major components to it. The data manager, which is really where all the core I/O is happening, that's what's doing protocol handling, provides the query query API and so forth. One second. And then there's the cluster manager portion. The cluster manager is really all about clustering the nodes together and understanding what the topology of the cluster and adjusting to topology changes and failures. Got a question?
Yeah, just a quick one. Instead of trying to write 100 million lines, is this presentation going to be available?
Yes. Question was, will the presentation be available afterward? And Oracle is posting them all. Absolutely. So let's drill into that just a little bit, not a lot. So there are effectively those two aspects to it. If you were to go one level deeper, what you see is inside the data management side of things, there are a few things that we've written that were needed to be really high performance, C-oriented. And that we based on memcached. We also built the query engine over there. Actually, parts of the query engine do use Erlang, and then we built a new persistence layer, and that's a very modern persistence layer. It's an append-only file format, which is generally the way to make something really, really reliable and fast. It's one of those space-time trade-off things, so it does trade off space, although we do address that with automatic compaction. Then there's the cluster management side, and again, this is really just about checking in on all the nodes, telling clients what's happening if we have topology changes, allowing you as a developer or maybe an ops guy to script up adding servers together, things of that nature. Oops. As mentioned earlier, it is both a distributed key value store and a document store. So that means that from your application perspective, you actually don't need to even really think about where these things are going. That's a really freeing sort of thing. You simply have a document, a name for the document, which is frequently called the key or the ID. You hand it off to this API and say, I'd like you to store this. I'm going to come back for it later. And then the cluster is responsible for all of that. You don't have to think about the sharding or how the sharding actually occurs. And so the verbs that we frequently use, because it has this memcached legacy, are things like set and get rather than put and so forth. From a key value store perspective, all items are stored and retrieved just using standard operations, and they're evenly distributed across the nodes of the cluster by way of vbuckets. Vbuckets are really just a layer of indirection. So when something that's kind of unique to Couchbase, there are a couple other NoSQL databases that work this way, but some of the systems in the category of NoSQL will have to do what are called metadata lookups or quorum reads, depending on how the system is built. And because of that, they either move more towards where they don't have consistency, or they have to do this metadata lookup, which increases the amount of work in order to access an individual piece of data. And that has an impact on a couple of things. One is it has an impact on throughput and latency, because if you're having to do a metadata lookup or a quorum read, that's just more work, and more work takes more time. The second area that has an impact is if you're doing something like quorum reads, and I don't want to say that quorum reads are bad. It's one of these things where I think there are scenarios where an AP type NoSQL database makes sense, but for the majority of scenarios, we believe a CP type system makes sense. The reason is you as an application developer, if you're writing code, I need to reference a document, and suddenly the database system comes back and says, well, I got these two. I'm not really sure which one's right. That's sort of you have to write your code very defensively. I would defer you to something like the Amazon Dynamo paper. There are good use cases. In Amazon's case, they talk about the fact that you can take the shopping cart, and if you have 2 requests for the shopping cart, and the system says, "Hey, I've got 2 shopping carts for you," well, that's pretty easy for Amazon. They just merge them. Right? There are scenarios where you can very easily come up with the algorithm, but the majority of scenarios, we believe that trading off momentary availability, we still have automatic failover, for purposes of consistency really makes for easier application development. So another couple things, we do store, if you do choose to store JSON documents into the system, now we can actually get some more information. So the database server understands what JSON is, and allows you to write additional code to be able to extract information from that JSON. So, we sort of, the giveaway here, right? We sort of jokingly talk about no schema, right? So, but realistically, it's flexible schema or implicit schema. So each document, when you write that application, you have entities. Those entities have certain attributes. When you store those documents to the system, you sometimes want to be able to go back and extract data from that system. And it doesn't matter, say, if 2 records for 2 individuals have slightly different format, and this is very liberating in that you don't have to work out how am I going to map my object level down to a relational model. I can simply store things as an aggregate and then be able to extract information back out of the system later. And you'll see some examples of that. Just very briefly to show you how this works from your application perspective to the cluster. When the application starts up, it's really just going to have a set of nodes that live out inside the cluster. If a new node happens to come online, we actually use a commit stream back to that client. So when a topology change occurs, when we add a new node to the cluster, we'll send a topology update to that client. This also works for failover, same methodology here. And once that new node comes online, now that client will immediately start using that new node. Also worth mentioning is just how do you start things up. It's actually quite simple. It'll look relatively restful from a client perspective. When you create the client, you're really just creating this Couchbase client object that has all those verbs, set, get, etc. It has the query API and access to the views. But really instantiating a client is just a matter of pointing it to 1 or more nodes in the cluster. Now, you'll notice that I may have a 100-node cluster, but I really only need to point it to 2 or 3. It will dynamically discover the rest of the cluster after it initially bootstraps. So this is just a RESTful bootstrap to understand where to start. You got to have a starting point. So frequently, that'll be maintained in a properties file or something like that. Yes, question? Sure. So the question is, what if one of those nodes happens to be down? That's why, and I sometimes get people give me a hard time because I forced the constructor to take a list, and so it will iterate through them until it finds one that's up. Yeah. So it'll take a little while to determine that, oh, that guy's not there. I'll move on and bootstrap somewhere else. Now, the one thing that you do need to be aware of, this is in our current client library, because we don't try to persist things to disk on our own or configuration or anything like that. One thing that you do need to be aware of is if you completely swap your cluster, and that does happen. Anyone use EC2 by chance? And around December of last year, if you got one of those emails, I don't know what happened exactly, but they basically said, everyone on East, please get off. So, and the neat thing was that we had a number of customers who were deployed, and it was really just a matter of, they could instantiate new nodes in the same region, but the ones that they were on, they had to move everything off of. So they just instantiated new nodes, completely swapped out the cluster, hit the rebalance button, all the data moves. Now, in that situation, you're going to want to change your bootstrap URIs because suddenly all of your nodes of the cluster change. Yeah, yes, exactly. Yeah. So, but we have that scenario covered. So with that, I'm going to turn it back over to Rags, and I'm going to come back a little later and do a bit more demonstration.
Right. So, like what I mentioned earlier, 80 to 95, maybe even 99% of the use cases are going to be based on primary key, and because of our history from memcached, which essentially takes care of persisting your primary keys. It takes care of hotkeys and all that. You don't have to worry about, how to access those keys, where they are distributed. All that is done by the infrastructure. But essentially, it provides a simple set of operations: add, replace, set, and so on. Very easy to figure out what they do just by looking at it. Okay, there is also a property called as TTL, which is time to live, and this might scare a little bit, some of the database programmers away. Basically, what happens is after that particular time, that document is no longer valid. Okay, this is true of a lot of those documents out there. Something may not be valid after a certain amount, certain time, or something may not be valid after 15 seconds in kind of like a gaming application that you're developing or something like that. So you can specify the TTL either as an absolute time or a relative time. Then there are a bunch of other things like get in touch, which updates the cache and so on. You can get bulk and so on. Okay. So here's one thing about Couchbase, which let me hold off on the questions if you don't mind. But essentially, one of the things about Couchbase is that pretty much everything is asynchronous. Okay, this got me the first time when I was doing it. When I was programming in Couchbase. Essentially, what you do is you set a future object, right, with the return value from the operation, and then when you go and do a get is when you're doing a block on the particular operation to complete. So what it allows you to do is it allows you to queue millions of operations per second, and only when you really need the result, that's when you go and get the result by just doing a get. As you can see here, basically what I'm doing is I'm doing a set, and I'm going around and doing whatever I want to do. But only when I want the result, then what I do is I go and do a get on the setup, and now I can look at the what happened to the operation and so on. So essentially, we are using a future object, just like a any other Java future object. And the strange thing is that even a get has an asynchronous version of it. Okay, like there is an async get. Okay, and it's exactly the same. So what it allows you to do is it allows you to queue operations as quickly as possible. How do you implement concurrency? There are two ways of implementing concurrency. One is the pessimistic concurrency using get locks, right? So you grab the lock and nobody else has access until a particular amount of time.
Just to jump in for a moment. So the issue is that once you move to a distributed system, now you need some new concurrency primitives in order to describe how that application and that distributed database operate together. You can't necessarily rely on, with the traditional RDBMS, everything's going to one place, right? So we need these new concurrency primitives, and we've added some of those.
Yeah. So essentially, one way of doing it is using the getL, which locks a resource, and until you unlock the resource, nobody has access, that particular piece of resource that you're interested in. This is, how you've done this in the past. The difference here is that there is a default of 30 seconds. Okay, so if you die within 30 seconds or something, then what happens is, that lock is released after 30 seconds. Typically that's more than enough. And then you can implement a graph of these different locks, to do long-lived transactions and so on. But a more interesting version of this is what is referred to as optimistic concurrency. And the philosophy behind this is that, these things happen. And when they happen, you would rather deal with it when they really happen than try to prevent them from happening. Okay? So what you do is you use what is referred to as a cache value, okay, which is basically a long value which is incremented every time you do a cache, in effect. And then what happens is you provide the cache value and say, set this only if the cache value matches. Okay? So if it matches, it's a success. If it's not, you get back a cache mismatch. Doesn't mean it's a failure, like what Matt was alluding to. you may need to merge the shopping carts, or you may need to merge the comments on a particular record or something like that, right? So the moment you get a cache mismatch, then the application can deal with it in the most appropriate manner, that the application really knows about it. Okay, so it doesn't mean so the top one is optimistic concurrency, and the other is is pessimistic concurrency. So far we talked about really Couchbase Server 1.8, okay, which is really pre-views and queries, okay, and like what Matt and I talked about earlier is now if you persist your data as JSON, you can pretty much slice and dice your data in any form that you want, okay. A lot of the use cases, let's say I'm Starbucks, I'm really interested in each of these different coffee shops, right? So I provide an ID and I look at each of those coffee shops. But as a user, I may be interested in all the coffee shops in San Francisco, right? Which is typically not a primary key kind of access, okay? So what you can do in those cases is if you persist your data as JSON, then you can say, get me all the coffee shops which are in this range of zip code, or which are in the state of California, or in the county of whatever, Sonoma, whatever this is, okay? So you can do something like that. So essentially, the view and query APIs allow you to do that. So the difference between Couchbase Server 2.0 and whatever was there earlier is that essentially it adds JSON-based storage. So the server looks at it and says, is it JSON? Okay? If it's JSON, then it does something special with it, right? If it's not JSON, it's just treated as a binary blob and it persists it. Okay? So just one thing to watch out here is if you might be thinking you're persisting in JSON, and that's happened to me a couple of times, okay? And you may, if you have a syntax error, then it ends up being a binary blob. So just watch out for that, okay? Views are materialized with indexes, and basically what this is secondary indexes which are stored on disks, okay? And we'll look at that really quickly. So essentially what views are, like I said, are different perspectives on the same data, and enable secondary indexes. And really, you can create secondary indexes on whatever it is that you want. You can create indexes on salary. You can create indexes on department number. You can create indexes on zip code, like I said before. You can create indexes on name, just about anything. All right? It uses something called as MapReduce. Don't shudder at the thought of MapReduce. It's basically the philosophy is just the same. Meaning, what you do is you take your task and break it down into chunks that each of these different nodes can operate on, and then you collate the results back and present it back to the user. It's the same philosophy, okay? And you express your MapReduce in what is referred to, in JavaScript, okay? And we'll see it's very simple. It emits key value pairs, and the key is the one that's used to, kind of sort your data, if you will, okay? And the values are used to aggregate, like for example, you can do count, sum, and stats, and so on. Okay, and we'll see some examples of that, and things become very clear. How are views materialized? They're materialized using indexes. These secondary indexes are stored on the different nodes, and like I said, they get brought together and presented back to the user. Okay? So a map function creates a mapping, okay, between the input data and how you want to see the data. That's really what it is. Okay, and reduce really provides a summary. There is a concept of what is re-reduce and all that, but we don't need to worry about that right now. Okay? So essentially what a map does is it outputs one or more rows of data, and associated with each row, there is a concept of what is referred to as a document ID. Okay? Although you won't be able to see it, you can access that using any of the language APIs, and we'll see that in the demo. Essentially what they do is they emit key and value pair. Okay, so key value pair. Okay, and that key will be used for sorting and querying and so on. And the key and the value itself is stored in the index. Okay, so what you want to be, you don't want to be tempted into a situation where you want to store the entire record as a value. Okay, because you always can get to the record by using the document ID, because that is available in the language API. And there are some ways in which you can optimize your views, because remember, these are all secondary indexes that are stored in those different nodes. And you may want to optimize it in a number of different ways, and we'll look at that in a little bit. So some of the rules associated with views are that all views, there is a concept of what is referred to as a design document, and within a design document there are a number of views. All the views within the design document is incrementally updated whenever any single view is accessed. So what you want to do is you want to put related views in in the same design document. Okay, there are a number of other optimization techniques as well. If the entire view is recreated, and you can create that using the admin console or using a REST-based program, there are a number of ways of doing that. Okay, if the view definition changes, then the entire secondary index is kind of thrown away and recreated. Okay, there are ways in which you can get the freshest data, but it's a trade-off against performance. Okay, they're always accessed lazily by default, meaning if nothing happens, if nobody accesses the view, nothing really happens. No big deal, right?
Another way to put this is it's an eventually consistent secondary index. And if any of you have ever used, say, Google Docs, I remember, it'd frequently be you'd invite somebody to a document, and then they'd go pull up their document list, and it wasn't listed there. They'd get the email and they'd have a direct link, but they wouldn't have it in their document list because the big Google MapReduce engine hadn't come along again and found it yet. So it's effectively the same idea. And for many, many use cases, it's actually a pretty useful thing. One that we toss out frequently is things like leaderboards. So you have an option of either having a consistent index at the cost of updating the index, or an inconsistent index at the and getting a performance advantage.
Yeah, no, that's a good segue. What if one of the coffee shops in San Francisco is missing? I think I can deal with it, right? Most of us can. But if you are really, if you want the latest coffee shop in San Francisco, you can say stale is equal to false, meaning I want the freshest data. And now what happens is when you're accessing the data, the indexes get updated. So, that's the trade-off you have to deal with. So you can set the stale is equal to false and work that way. So the index information is stored on the disk. And like I said, it's all stored decentralized. And this kind of picture kind of illustrates this. All the indexing work is distributed amongst the different nodes. And then essentially what happens is whenever you do a query, they're kind of brought together and presented back to the user. This is in principle. All right? So we have some data, essentially we have, if you install the latest server, we have beer data, okay, and we have, I also work on precedence data. So essentially we have all the, 44 precedents with all that information associated. So you kind of play around with this, especially with views and queries. And this is typically how a map function is, is expressed. This is in JavaScript, okay, it's somewhat different, but it's pretty much the same. Okay. Essentially, I'm specifying the map function, and basically I'm saying if the type is precedent, okay, and there is a home state, then what I do is emit the home state and the name. I could emit really just about anything that I want. Okay. So what it's going to do is it's going to organize it in terms of home state. Very straightforward. All right. So conceptually, this is kind of how it looks. Arkansas, value Bill Clinton, California, or Richard Nixon, and so on and so forth. All right. In addition to the map function, you can define a reduce function as well. Okay. There are 3 inbuilt functions. One is count, and the other one is sum, and the other is stats. Okay. Stats gives a lot of statistical information. Count is very straightforward count, and sum is sum. All right. So basically, if I'm using the count function, then your reduce function kind of looks something along these lines. Not exactly the same, but basically it spits out Arkansas, Bill Clinton, California, Richard Nixon, Ronald Reagan, Georgia, and then Illinois, whatever, right? And then what it does is, in the reduce function, it basically takes the array of values and counts the length of the values, which is really the the count that's going to be finally emitted out. Okay, so the conceptual result of the reduce will be something along these lines: what home state and what's the value, the count of the number of precedents in that particular home state. Does that make sense? Okay. This is a little bit more interesting example, and again, this view is already available to you if you just install the Couchbase server with some of the the sample buckets. Essentially, what I'm doing here is I'm sorting on country, state, and city. Okay, so if there is no state, then I do country and state. If there is no state, then I do country alone. All right. So with just one map function, what I can do is I can sort by country, state, city, or by country, state, or by country, city. I mean by country, all right? And we'll see some examples of this as we go along. And all that I'm doing is I'm counting the, the number of rows in that, which basically belong to the category, all right? So I could say something like, get me all the, or the sum of all the breweries, in San Francisco, in USA, in California, and San Francisco. I can do that. Yeah. Okay, yeah, that's a good point. And you saw that it was not available before. But basically, meta is for getting at the metadata. Okay, like for example, I talked about the CAS value. Remember that? And the TTL. Some of those can be. I don't think the CAS is available, but the TTL is available, and there are certain other parameters available as well. We can take a look at that. Okay, like the ID. ID is part of the meta, okay? Yeah, basically what I'm doing is I'm emitting one for each, because what I'm doing ultimately is I'm doing a count, right? So, essentially count will kind of add those up, yeah. If I'm doing some, let's say I'm doing some batting averages of baseball players or something like that, right? Then I might do it a little bit differently. I might emit the batting average and then do a stats or sum or something and then divide it. So that's going to be a little different. So here's the interesting part, right? If I do a group level is equal to 1, then it groups by country. If I do group level 2, then I do country and state. Group level 3, then it does country, state, and city, and so on. Okay? And we'll see some examples of that as well. So how do I use the query API? Essentially what I do is I set a number of properties in the query. Like for example, I'm saying set reduce as false, set include docs as true. What that means is I can get at the document itself just by looking at the particular row. Set stale.false, which means I'm getting the freshest data. All right. The view API, very simple. It associates the view, okay, the design document and the view name. Okay, and then what I do is once I get the view, then I iterate through each of those rows in the view, and then based on each of those different rows, I do whatever it is that I want to do. Okay, essentially what I'm doing here is I'm just getting the document and I'm done. Okay, but I could do anything I want. And we'll see in a little bit. Okay, so here's an example of what I'm doing. I'm getting precedent by state. Remember what I did was I emitted the home state. And then I did a count, right? So what it's going to do is it's going to give me the state and how many precedents hail from that particular state, okay? So when I do a row.getKey, it's going to give me the state, and row.getValue is going to give me the count of the precedents that hail from that state. Does that make sense? Yeah. So it kind of looks something like this, okay? And we'll see an example of this in a little bit. So that kind of has 44 precedents, I think. Okay, so let's do the demos. I will switch to 1. All right, that's good. So here's a cluster. Essentially I have a 2-node cluster. Okay, everybody see that? Basically it's 2-node. It's running on EC2. We use right scale and go through that on EC2. And what I can do is I can drill down on pretty gory detail and look at what is happening on that particular node, or kind of look across the cluster. Okay, so now since I know that you are all developers and you probably don't care too much about this, but the fact is that it's very simple, and even from a development perspective, you get a lot of information. Like when I was debugging a tap operation, that all that I did was I kind of looked at the tap queues and kind of tried to figure out what was happening there. So you can kind of figure out what's going on by just looking through this jQuery graphs. It's pretty and it's kind of neat and it's definitely geeky. Okay. So what I'll do more to the point is, here's a load that's running. Okay, and I will show how easy it is, to add a server. Okay, so here's another server. Okay, I mean a node 184, 169, 193, 28, whatever. Let's not worry about that. Okay, so what I can do is I can set it up very simple. I can just set it to let's do.
Oh, you're doing join.
Yeah, or I can do a giant. Yeah, I could basically what I could do is I could go back and join to the original one. Okay, so which is 50.18.137.221. You don't have to remember. It could be well qualified names as well. Okay, and essentially what I'm doing at this point is I'm joining this node to the cluster. Okay, and you will notice when I go back to the server. Okay, you will see that there is one node which is pending a rebalance. Okay, and if you notice here, okay, your node should also be. Okay. It should still be serving that load. Okay, and really, the way I can do a rebalance is just hit the rebalance, and the node is going to be load is going to be continue to be served while the rebalance is still happening. Okay.
This entire UI was actually built on that same REST interface I talked about earlier. So realistically, this UI, this index.html, is really just an HTML page with a bunch of divs that get manipulated by jQuery, and it's true across all nodes of the cluster. So from an administrator or developer perspective, it's pretty useful to know that anything that you can do there is actually doable from programmatically as well. Also made it easier for us to implement.
Okay. So, you don't really have to use EC2, right scale, and all that. This is running on my laptop, actually. And here, I have a bunch of data buckets defined. Okay, and this is my default data bucket. I can take a look at this as well. Okay, but what I'm going to do is I'm going to show you the view that I defined earlier. Okay, let me see if I can make this look a little bit better. Okay, so here's my my map code, right? Can everybody see that? Basically, I have doc type is precedent. Then what I'm doing is I'm emitting home state, and I'm emitting the name. Okay, so typically what I do is I debug my MapReduce code like this. Okay, so here you can see that the value is 44 because what I did was I really reduced the result. So essentially, it told me that there are 44 precedents. Big deal, right? So let me go back and do this, which is I remove the reduce function. Now we can see that Arkansas has Bill Clinton, California has Richard Nixon, and so on and so forth. All right? Is everybody with me? Now, basically, what I'll do is I'll go back and add the reduce function. Okay, and we'll see how we can access this in Java, which is really pretty straightforward. Okay, so here's my. You want to make a comment, Matt? Or yeah. So basically, what I'm doing here is I'm using the JSON libraries. Okay, let me make this a little bit bigger. Okay, you can really use any JSON library that you want. That suits your fancy. Jettison, JSON, whatever, right? And all that I'm doing here is I'm accessing the view, precedent by state. Okay, and then I'm saying set reduce as true. I set stale false, not that it matters much in this case. And I include the docs, and I'm setting the descending to be true. So it's going to start from, I don't know, Wisconsin, whatever, right? Whoever was the first president. Okay, and then I do the client query, and then essentially what I do is I iterate through each of the rows, and I display the value. Okay, pretty straightforward. Okay. So all that I'm going to do is I'm going to run that.
And so the thing to sort of focus on is that if you have that data that goes into that system, you don't have to worry about the format of the data. You can effectively just do regular programming around whatever the entities are, whatever the objects are, have some library turn that into JSON for you, and then when you want to query it, that's really when you can start to work out what is the information I need to query on, and I build up the secondary indexes. Yeah,
so essentially, since I had descending, it started with Virginia and so on. Okay, So you can see, Virginia had 5 presidents and Texas had 4 and so on and so forth. Okay? I can go on with the president example, but that's not as interesting as the beer example. Okay? So this one is a beer level, and basically what I'm showing here is access to another query. Okay, and what I'm doing here is by location, and if you guys remember, what it would do was sort by country, by state, and by city. Okay, and how you do that is just by setting the level. Okay, I'm setting group level to 3. Okay, so if I set the group level to 1, then it's going to sort by country. If I do group level 2, then it's going to do country and state. Okay, if I do 3, then I'm doing country, state, and city. Okay, so very simple. I'm going to run this, and we'll see what happens. Okay, and you'll see, Argentina, Aruba, and so on and so forth. I've set the limit to 30. Okay, if I take out the limit, then you'll see everything in there. So being from India, I'm curious how many beers are made in India. Okay, so let me try this. So basically, what I'm saying is get me everything in India. Okay, and let me go up all the way to Japan. All right, so I'm doing this, and let me run this, and we'll see what happens here. Is basically India, in Bangalore, which is where I come from. Proud that at least there's one. I'm sure this is not the latest. Okay. And then, we have a bunch of those as well. And then, of course, we have Ireland, which beats us handy, the beer country. But in any case, so you get the point about how you can use, you cannot really do random queries, okay? We have a project going on, where you can do random text searches. But that's not, part of the official product.
Yeah, it's a different way to state it is that you don't do ad hoc querying like you might do with a traditional relational database. And if anyone is aware of this, I'm sure you've all done this, right? You do an ad hoc query on a very large system used in production, and suddenly, basically
exactly.
the system goes away. Let's hold questions if we can until the end, just we're almost out of time.
Yeah.
So there's no ad hoc query capability, but that's also part of how we keep the system fast all the time. So you are doing some definition of the things that you're querying.
Yeah, and if again, if you're really concerned about performance and don't really care about the latest fresh data, then you can set stale to true. Okay, in which case you're okay with the later, the old data. All right. So hopefully that kind of gave you an idea of how you can persist your your data in JSON, and then kind of slice and dice it in multiple different ways. With that, we have a little bit more, and let me bring Matt back again.
Sorry. So we have about 8 minutes remaining. So I just want to walk through a couple situations where people use this and then do one more demonstration. So one example here is Orbitz. Orbitz is a Java deployment, and very recently, they shifted their hotel queries. So the data behind the hotels is actually running on a series of Couchbase clusters. It's 10 nodes currently across 2 different data centers, and they're planning to expand that a little bit to other environments. There's just to show how things changed. So what they were after was going from their previous system to a new system. They wanted to reduce the latency, the max latency and the average latency. So this is showing average latency, and you can see that it was deployed on 9.6. So good change in average latency. Of course, the big one is max latency. Anyone ever do a search, right? And that search, there's been lots of good statistics about this, where if it goes on for 2 seconds or something like that, you get pages abandoned, which is pretty bad. So they wanted to be able to change that. And so you can see max latency came down from around a second in most cases, but some outliers up there all the way up to 2 seconds to I think something like 50 milliseconds or something along those lines. I saw I'll get to questions in just a moment. So. Another use case, just so I can get to the demonstration, is ad targeting. So I'm going through this fairly quickly, but I'm happy to talk about it later. Everyone from AdScale to AOL advertising to Chango, the ad space is really it's a really interesting market. There's ad retargeting and so forth. So it's not just ad displays as My mind sort of understood it. It's a really complicated market, lots of different players in that market. But a common use case, because of that consistent high throughput, low latency, has been deploying Couchbase to ad targeting. And that one is kind of interesting because it also brings that other NoSQL player into the loop, the one I'd mentioned earlier, Hadoop. So in both AOL's case and others, they'll develop events over the course of the day, and either through Flume or through log imports or other way. In AOL's case, they actually put the data into Couchbase and then move it over to Hadoop later. They'll gather events over the course of the day, and what they're trying to do is build a profile about the users so that they can decide when they need to display an ad, what ad to display. So based on the profile, real-time campaign statistics, et cetera, they'll display that. Just briefly looking at what that flow looks like, and to show you what I'm going to demonstrate here in just a second, is that the moving parts are you have all the users hitting the ad targeting platform. That ad targeting platform is generating logs as well as directly accessing the Couchbase cluster. So they have that little box on the page, and the SLAs for ad targeting, by the way, are very low. It's the service level, you have to be in 40 milliseconds. And so if you can get your data in a millisecond, then you can spend a whole 39 milliseconds on your algorithm to determine what ad to display. So that's a big win. So they wanted to be able to get that information as fast as possible, and that happens through the Couchbase cluster. And I'm not dissing Hadoop, but I'm just kind of pointing out the difference. Anyone have a guess as to what the latency would be for getting something out of a Hadoop MapReduce job? Right, it's in typically in seconds or minutes. And that's for small quantities of data. So Hadoop is designed for heavy lifting, lots of data. Couchbase is designed for that interactive set of data. But we can move data back and forth between them. So we actually built a scoop connector. We did that in conjunction with Cloudera. We actually certified that connector along with them. And so I want to show that as a quick demonstration with the minute or so we have left. So what I have here is yet another cluster. This is a cluster of 2 nodes. I have a 2-node cluster and a 2-node Couchbase cluster and a 2-node Hadoop cluster. So I have a couple task trackers out there. This is the Cloudera manager. And then what I'm going to do is I'm going to kick off a scoop job. First I have to remove my previous data just to make sure that when I dump the data. And so now I'm going to run that scoop job. What this is going to do is scoop dynamically generates the code. So you as a Java developer, you can certainly use your own objects, whatever it is you're storing inside. We typically are using JSON, but you can use you can use just serialized Java objects. And then the scoop connector can actually get whatever information is appropriate out of that Java object. The default is everything goes to a string, and it's in the process of dumping that data from the Couchbase cluster to the Hadoop cluster. There's also an option for backfill, and what that does is it does sampling for a period of time. So sometimes you don't need a lot of data, you just need a little bit of data. The interesting thing about this is, and there's a good presentation from my colleague Dan Templeton over at Cloudera. The way we do this is by generating a bit of code and shoving it into the Hadoop cluster, and then that Hadoop cluster attacks the Couchbase cluster. That's basically what's happening. It says, give me all your data. And so if you had a 20-node Hadoop cluster and a 20-node Couchbase cluster, it's going to automatically distribute that job relative to how you might have done that previously with, say, ETL or something along those lines. So with that, I think, are we at time?
I think we're out of time.
Yeah, we are out of time. We will certainly be available for additional questions, or we might be able to go a minute or so over. Really quickly, any questions out there?
We have some T-shirts too to give out. So
he's jumping up. So versus comparison to Cassandra. Yeah, so the question is comparison to other major NoSQL players. It depends, right? So we're document-oriented. We think that's the right model versus column groups and super columns, for example. The other thing is that we do have, as I mentioned earlier, that thing where we don't have to do metadata lookups, and that gives us a lot of the speed and performance advantages. There are a number of other ways to put it together. For example, you saw how quickly it is to cluster a system. It's that we've put a lot of focus in making sure it's really easy to set up and manage a cluster. And we've pounded the heck out of this thing by working with Zynga and others. So, sorry, I don't know where to go next. I'll pop up here. Yep.
So I've used CouchDB in the past. I've used Ectorp as an ORM-like solution.
Yeah.
Connect to it. Is there anything like that for Couchbase?
Yeah, so just to repeat the question is he's used CouchDB, Apache CouchDB in the past, and there's something called Ectorp, which is basically an ODM, object data document mapper. People do actually use Ectorp to some degree with other components of Couchbase. We don't have anything directly for Couchbase Server 2.0. But it shouldn't be terribly hard to use the two. The View API is mostly the same. There are a couple slight variations. But Henrik, the Ectorp maintainer, we have a good relationship with him, mostly on the mobile side, which wasn't the focus of this morning's talk. Yeah, another question.
Yeah. Is it possible to handle query results as a stream, or are you pulling everything to RAM?
Is it possible to handle, question is it possible to handle query results as a stream?
Stream, yeah.
Yeah, and so not exactly, we showed the iterator example, and really what's happening under the covers is the iterator is doing is streaming the query results for you. And so if, say, you were to have billions of items, you can just use an iterator and iterate over what comes back, and the Couchbase client will handle all of that for you.
You could potentially use REST, right?
Yeah,
if
the REST API itself is documented, so if you did want to go straight to it and stream the data, there's no problem. I think I'm going to, I know there are a few other questions. By all means, please come on up here, and sorry for not being able to answer all the questions. Hope it was useful, and thank you very much.
Thank you.